Section 4.7, completing the square. The essential question today is, what technique can I use to take a quadratic equation standard form and transform it into vertex form? We'll talk more about what that means. Word of caution, completing the square, it's a stumbling block to many. If you remember the steps, you will be fine. Don't remember the steps, it's going to be very hard to figure out what you're doing. So, first of all, why are we doing this? Okay, think back to the very beginning of the chapter. We had some quadratics in standard form. Y equals ax squared plus bx plus c. And that told us some information about the parabola. We also had another form called vertex form, and that was in the form y equals a times x minus h squared plus k. Now, on the test, you remember there was a question that said, hey, I want to take the equation and take it from vertex form and put it into standard form. And hopefully you remember the way you do that is FOIL. I sort of take care of this square, FOIL things out, combine like terms, and all of a sudden it is in standard form. But sometimes it is helpful, because standard form can be a little bit unwieldy. Sometimes it is helpful to take an equation and put it from standard form back into vertex form. And the reason why is because if you have it in vertex form, you can see the vertex instantly. And that's very useful. So the question is, how do we do this? Yes, how? So before we tell you how, and by we I mean me, myself, I'm going to show you some other things, okay? And these things are going to be helpful for us. First of all, something that we've seen before but not talked in depth about is these things called perfect square trinomials. This is a perfect square trinomial. Here's why. When you factor it, remember, I'm trying to see what adds to the -6 and multiplies to the 9. It happens to be -3 and -3. And take a look at what's going on here. This binomial is the same as this binomial. So if I wanted, and this is typically a good thing to do, you can write this as x minus 3 squared, because there are two of them. This is a perfect square trinomial because when you factor it, it makes a perfect square. That's pretty cool. So let's go over here. We want to invent a perfect square trinomial. Notice how I definitely have a -10x in the middle, and I'm going to be able to pick any number over here. Now let's think about this. If I want to make a perfect square trinomial, I need to have the same thing here as with here. Now, if I'm trying to add to -10, because remember we add to the thing in the middle and multiply to the thing on the right, let's think about how I would do that. How could I add to -10 so that this number and this number are exactly the same? -5 and -5 should do the trick, right? -5 plus -5 is -10. And -5 and -5 are the same thing. So I could write this as a perfect square trinomial. Now, in order for that to happen, what does the trinomial need to look like? Is this going to be acceptable? Well, no, because -5 times -5 is not -2. So what do I need to put over here to make it work? What's -5 times -5? Oh, it's 25, positive 25. So this is a perfect square trinomial. And the way I could figure out how to make it a perfect square trinomial is look to see, hey, what would I need in order to get a perfect square? What adds to -10 that is the same? Then I multiplied those two things to figure out what needs to be here to make it work. So here's how we're going to use this stuff. I have an equation, x squared minus 10x plus 22. Right now it is in standard form, right? I have an ax squared plus bx plus c. But I want to take this equation and eventually have it in y equals a times x minus h squared plus k form. To do that, I need to have a perfect square trinomial. Is this a perfect square trinomial? Well, right now it's not, because if I were to factor this, I'm not going to be able to find any numbers that multiply to 22 and add to -10. It just doesn't happen. So let's ignore the 22 for now. Let's say, hey, This 22, it's not doing what I want. I'm going to set it way over here to the side, and I'm going to stick a number right here that does make a perfect square trinomial. So remember, to make a perfect square trinomial, I need to find something that adds to -10 that's the same so that I can have exactly the same factors. And we decided on the last slide that with -10, that number was -5, because -5 plus -5 gives me -10. Awesome. Keep in mind the number that we decided that would do that is 25, because -5 times -5 is 25. If you were to factor this, what adds to -10 and multiplies to 25, you would get -5 and -5. Now, there are a couple things that are sketchy about what I just did. First of all, I just added a random number onto that side of the equation. Am I allowed to do that? No. So what do I have to do in order to balance it? Well, there are a couple things I could do. First of all, I could add 25 to the other side of the equation. That would be a legit thing to do. Or, think about this, couldn't I subtract 25 from this side of the equation? Because think about it, if I add 25 and then subtract 25, what have I really added to this side? 0. 25 minus 25 is 0. So the other sketchy thing is, really I only factored this part, right? This part factors into x minus 5 times x minus 5. That's going to be x minus 5 squared, so that's good. But I still have to take care of the plus 22 and this new minus 25 on the right-hand side. So let's combine those like terms. 22 minus 25 is -3. Hey, look, I have it in vertex form. That was very cool. Let's talk about the steps of what I did though, because this is all a little convoluted. Keep in mind, what I did first is I put 22 to the side. I don't need to worry about this 22 right now. I put it to the side. Second, I figured out what number do I need to have in my parentheses that's going to be able to add to -10 and be the same. We decided that number was -5 and 5. Third, I added 25 into my trinomial, and the reason I did that was because that's the trinomial that's going to factor to this. And because I added 25, I had to subtract 25 outside. Fourth and finally, I just simplified like terms. I said x minus 5 times x minus 5 is x minus 5 squared. I said 22 minus 25 is -3. This is an equation in vertex form, and if you remember, as a bonus, the vertex is going to be 5, 3. Now, in the next example, I'm going to discuss some tricks for you. Okay? So keep in mind, I'm trying to convert this to, I don't mean to say standard form, I mean to say vertex form. There we go. So remember, my goal in my first step is to get a perfect square trinomial, and this is not a perfect square trinomial. What multiplies to 4? 4 times 1, is that going to add up to 12? No. 2 times 2, is that going to add up to 12? No. So this is not a perfect square trinomial. So for my first step, I need to set 4 to the side and just worry about getting a perfect square trinomial. So I'm setting 4 to the side. I need to get a perfect square trinomial. I need this to factor to x plus or minus something and x plus or minus something. In our second step, we have to decide what that something is. What's going to add to 12 that is the same? Well, obviously 6 and 6. 6 plus 6 is 12. Third, though, I need to actually make sure that I have a perfect square trinomial. What would need to be in this spot so that when I factor it, it actually indeed does factor to x plus 6 times x plus 6. So here's my third step. And remember, I find that by multiplying. 6 times 6 is 36. And remember, if we just look at x squared plus 12x plus 36 in a vacuum, that should factor to this. What adds to 12 and multiplies to 36? It's 6 and 6. Keep in mind, though, the other part of the third step is that since I added 36 in there, I also need to subtract 36, and that is to keep my equation balanced. If I add 36, in order to keep things balanced, I also need to subtract 36. That way I'm adding 0 overall. Okay, so fourth and final step, I just need to simplify some things. So let's make sure to write x plus 6 as x plus 6 squared. And don't forget to combine like terms. 4 minus 36 is minus 32. Voila, here is my equation. And keep in mind, this is in vertex form, so we can very easily see, hey, the vertex, negative 6, negative 32. Awesome. As a summary, remember, completing the square is all about manufacturing a perfect square trinomial. So my goal is to take whatever situation I have, maybe it's something like this, and I need to figure out, hey, what number is going to go here so that when I factor it, I have a perfect square trinomial. In this case, I would think, hey, what number that's the same adds to negative 4? That's negative 2 and negative 2. Okay, so what number needs to belong here so that when I multiply, I get negative 2 and 2? Well, that would be positive 4. Negative 2 times negative 2 is positive 4. Thanks for watching, guys. Hey, I know there were a lot of steps in this video. Maybe go back and just watch one more example again. Like, it makes sense mathematically. It's just a little tricky to keep all the steps straight in your mind. But we'll practice this more when we get back on Monday. Enjoy.